While explaining mesh analysis in my previous video regarding basic nodal and mesh analysis, I had some issue and my phone stopped recording in the midway, so here we are completing the entire topic. With mesh analysis we are using mesh currents and we are using KVL, and it is applicable for planar circuits only. Planar means a circuit which lies on a particular plane. So here what we are taking into consideration, we are taking some arbitrary direction and we are having a mesh current. Okay, we can take any direction we want, and as per the calculation, if the results comes out negative, the direction which we have taken is actually the other way around. So while writing the answer, you just reverse the direction. Okay, what you have assumed in the answer, you have to reverse the direction in case you are having an answer with a negative sign. So this is basic stuff what we have done so far. Then we have two situations here. First situation is when we are having a current source over here. Okay, we are having it in a reduced format because I2 will tend to be -5. Here we are taking the current direction to be so, while 5 ampere is going the other way around, so I2 equals to -5 ampere. Then we have the second condition over here, which is when we have a current source between the two meshes. So what we do here, we just eliminate this, okay, and we change the circuit into this format. This is called a super mesh. Okay, now we are applying equations as per these directions. So here it is -20 because we are taking current in this format, and from the previous lectures you have seen that when current enters the negative terminal, we take it as minus. Okay, and then we have 6i1, and then we take the root of this I2. Okay, plus 10i2, then we have 4i2. This I1 follows this thing and this element and this element. Okay, then we have I2 which follows this element and this element. So we have this equation, and on solving we have this, and we have KCL at node, which leads to I2 equals to I1 and I1 equals to so and so. Okay, super mesh has some following some following benefits. Sorry, it has some following benefits is that it provides constraints equations to solve for mesh currents, and a super mesh has no current. Okay, it requires application of both KVL and KCL. Here we have applied the KVL and now we are applying KCL. Okay, we are using both in case of a super mesh, and a super mesh doesn't have any current on its own. Now we have some important things to remember regarding both nodal and mesh analysis. Okay, if the number of nodes is greater, we use mesh analysis. If the or vice versa. Okay, if we are having lesser number of nodes, we prefer nodal analysis. If we have lesser number of meshes, we prefer mesh analysis. In case someone is asking in the question, it is asked about nodal voltage, we use nodal analysis, and when it is asked about mesh current, we use mesh analysis. So this is all for mesh analysis.